This video is still talking about compound probability, but now we're going to be talking about with replacement. So we're going to be talking about the independent and dependence of compound probability. A bag contains 4 blue marbles, 6 green marbles, and 3 yellow marbles. If 2 marbles, so we have 2 marbles are drawn at random, that means that this will be a compound probability. 2 marbles are drawn. This means compound. What's the probability of? We have 2 different examples, which have 2 different parts. Anytime we have to deal with probability, we have to know how many total we're dealing with. What is the total? We have 4 blue, 6 green, and 3 yellow. That is a total of 13 marbles. So we want to know the probability that drawing a green marble. What is the probability of first drawing a green marble and then drawing a yellow marble? So we're being very specific. We want a green marble and then a yellow marble. Now, it all depends on if it is independent or dependent. It's independent if the first probability will not affect the second one. So if I draw out a green marble, but then I put it back in the bag, I have the same amount of marbles in there. That means that this will be independent. With replacement means that we are dealing with independent. These are independent. Independent. Now there is crucial words in here. It says and then. That means I have to get the green one first and then the yellow one. Crucial words, because if it did not say and then, I could actually double my probability. What that means is I want a green one first, then I want the yellow one. But if it just said drawing a green and drawing a yellow, I could have a green one first and then a yellow, or I could have a yellow one and then a green one. So I actually have 2 possibilities of that happening. But because the words say and then, that tells me I have to have it in this specific order. My chances have actually decreased because I have to have it in this very specific order. So we want to draw a green marble first and then draw a yellow marble with replacement. So we write out the probability of a green, so P of green, and, so that's the intersection, so intersection. The second event is your yellow marble. We just want the yellow marble, P of yellow. Now, because I'm replacing it, because it says with replacement, that means I'm literally putting that green marble back in the bag. So now I still have 13 marbles in the bag. I can end that because these are just basic probabilities. We need to know the probability of a green marble. Probability of a green, we want how many ways can a green happen. There are 6 green marbles there total. So we have 6 out of, there are 13 total marbles. The intersection means we're multiplying. Now we just do our second event. This is just a basic probability. We want the probability of yellow. There are 3 yellow marbles. So there's 3 ways we could pull out a yellow out of 13 total marbles, because when we pick out the green one, we put it back in. So there's still 13 marbles in the bag. Now we just multiply. So multiplication goes straight across. So 6 times 3 is 18 over 13 times 13 is 169. If we plug that into our calculator, we'll end up writing, I'm going to write out another way of writing the notation. P of G for green, intersect Y for yellow. This is the probability of green and yellow is equal to, or is approximately 0.107. We have a small chance of getting a green one first and then getting a yellow one because we wanted to go in very specific order. If I had just said, so this was talking about earlier, if it did not have this very specific wording and then, if it just said first drawing a green marble and drawing a yellow marble, not the then, if it didn't say then, I could take my green and yellow, but then I can also do yellow and green, so I could have this one twice. It would be the same probability twice, so I'd actually double my chances because it wouldn't matter which order I got it in. But because this one says very specifically, I have to get the green one first and then the yellow one. I have to be a very specific probability. Now, I'm going to do the same problem, but without replacement. What that means is that when you draw that green marble, we are going to keep that green marble out of the bag, and that means that the second probability will actually change because my total number will change. So this becomes dependent. Without replacement becomes dependent. Because it becomes dependent, we have to write it slightly different. We're still going to write the first probability because the first probability has not changed. First drawing a green marble. That will not change. The probability of green. We want green. Intersect. Now we want the second marble to be yellow, but we did not replace the original green one. So the way we write this is the P of yellow. But we don't stop it yet because we have to make sure we note that we never put that green one back. So we put a vertical line that stands for given that, and it's telling us that we didn't replace this green one. So we have to put given that green. So I'm going to write out what this means. This vertical line means given that. And it really talks about given that we've already drawn the green and we did not replace it. So we've given that we've already drawn the green and we did not put it back. That means that the green one is out of the entire bag. That one green marble is gone. So if we do our probabilities, we're going to do our first probability like normal because this is just written normally. We have P of green. This does not have anything funky on it, so we write out our regular probability. So starting over, there are 6 green marbles out of 13 marbles total. And, so that means we multiply. How many yellow marbles are there still total? We only pulled out a green one. We have a green one out of the bag. So how many yellow ones are there? We still have 3 yellow ones. We never put that green one back, so how many marbles do we actually have in the bag? There's actually only 12 marbles in the bag now. This is why these would be dependent, because the denominator had to change. So we still multiply. We get 6 times 3 is 18, over 13 times 12 is 156. Now we're just going to write it as a decimal. I'm going to write out the notation differently like I did over here for this answer. I'm going to put P of G for green, intersect Y given G. So that's Y given that we never replaced the green. Is approximately, so 18 out of 156 is 0.115. Now this probability has actually increased from the first one. Now why is that? We actually have less marbles to choose from, but we still only have the 3. We want to pull out one of the 3 yellow marbles, but we have less marbles to choose from, so that means we have a higher chance of us getting the one we want. So that means our probability has actually increased. This next example is drawing 2 blue marbles. Now if it's saying drawing 2 blue marbles, we're still drawing 2 marbles one at a time. So that means I want to draw a blue marble and then a blue marble. So that means 2 blue marbles in a row. Anytime it's talking about 2 of something or 3 of something, that means in a row. In a row. Now, with replacement, that means I'm going to pull out a blue marble, but I'm going to put it back into the bag, so nothing will change. That means that this is independent. I can just do my basic probabilities and multiply them. So I want the probability of a blue marble And then I want the probability. So my next marble I want to be blue again. So I want probability of blue. Now, since we're replacing it, that means that this one does not change. This probability does not get weird. So I just say I close it. Because it's an and, we need to multiply. So the probability of blue, up here there are 4 blue marbles. There are 4 total blue marbles out of 13 total marbles. Times, because we replaced it, nothing changed from my first one. So I put that blue marble back, so I still have 4 blue marbles in the bag, and I still have 13 marbles total. So that would be 4 times 4 is 16. Out of 13 times 13 is 169. So we want P of B intersect B. This probability of blue intersect blue. That will give us approximately, because I want them in a row, because I want the same color, I'm probably going to have a very small chance of this happening. And the value will be 0.0947. You do want to go to 3 significant figures. We want to go, so we have that 0 in the front, we keep it, but then we still want 3 actual numbers after it, 3 significant figures. So this is a small chance of it happening, but it does have a chance. Now this last one over here, I still want to get the 2 blue marbles in a row, but I am not replacing the first blue marble. So if we write this out, my first draw is just normal. I want to make sure that I get the blue marble. Probability of blue. I want the blue marble. And then I want another blue marble. But I did not replace it. So that means I have to draw that. Given that, I already drew what we right after here is whatever our first event was. So I want another blue marble, but I never put back the first blue marble. So I have to put, given that we never put back the other blue marble. So it's all about understanding its reading comprehension. We want 2 blue marbles. This is our first blue marble. This is our second blue marble. The without replacement means I never put back the first one. So whatever is in that first one, I have to say I never put back that first one. Since this one is written like normal, it's just probability of blue. So we basically started over this problem. There are 4 blue marbles in the bag. And there are 13 total marbles in the bag. Intersect means times. Now, probability of blue given blue. What that means is I want a blue one, but I never put back the other blue. So there were 4, but I never put back this one that I pulled out. So how many blue ones are left? There's only 3 blue ones that are left because I never put back this blue. And then how many actual marbles are there left in the bag because I never put this one back? There's only 12 marbles left in the bag. So 4 times 3 is 12 over 156. So to write this out in different notation, it would be P of B intersect B given B is approximately. So we're going to do the same thing, 3 significant figures. And now we have less marbles to choose from, but we also have less blue marbles. So our probability will probably get smaller from the first time because we have a less chance of us getting this one and getting the exact same color. This will be approximately 0.0769. We want 3 significant figures. So that first 0 is not a significant figure, so we still have to write it, but we have to write the next 3 significant ones. And that probability is slightly smaller because it's harder to get the colors you want if you have less of the colors to choose from.